Hello everyone, welcome to the series of the USCIS Coding Challenge application video walkthrough. In this channel, you are going to see how Anika Vital Team prepares, designs, and implements a system with application and infrastructure components and pack the solution to meet the customer's requirement. In the previous sessions, we have covered system design, development, and operation. Today, we will have the last session to review some challenges we had and how we can do better next time. I wish it does not only explain how our team solved the problem, but also give you an idea on how to choose the appropriate technologies to meet your customers' requirements. For today's session, I divide the content into 3 parts. We will start with the topic regarding single or multiple code repositories. After that, we'll look at the 2 hosting options for our Jenkins build agent. We will end this session by discussing how to choose team members between single responsibility and full stack engineers. Okay, let's get started with the code repository. Separating microservices into multiple repositories versus having a single repository is a common architecture and organizational decision. We started with a single code repository and put multiple microservices into the same repository's different folders, but switched to separated repositories during the implementation phase with considerable efforts of migration. Each option has its own pros and cons. The benefits of splitting the services into multiple repositories includes improved autonomy for teams. Each team can manage their service independently without being affected by changes in other microservices. Teams can choose their preferred tech stack, tools, and versioning strategies without impacting other teams. Simplified dependency management. Each repository has its own dependencies and build process, which reduces the risk of dependency conflicts. Enhanced code isolation. Isolating services into their own repositories enforces modularity and reduces accidental coupling between services. Developers are less likely to create shared, tightly coupled code. Scalability of CI/CD pipelines. CI/CD pipelines for each repository are smaller and easier to configure since they only focus on the service at hand. Builds and deployments became faster since only one service is built or tested when changes are made. Clearer access control. You can manage permissions more easily by restricting access to a specific service repository based on the team responsibility. Reduced risk of breaking changes. Change to one microservice does not affect other services as long as contracts, for example, the API, remain stable. Easier migration and refactoring. Moving a service to a new infrastructure, tech stack, or even a different organization is easier since it's isolated in its own repo. However, separate repositories also have drawbacks, such as cross-service changes are harder. If you need to make a change that spans multiple services, for example, an API contract update, it becomes harder to coordinate across repositories, Separate CI/CD pipelines may complicate the testing and deployment of changes spanning multiple services. Duplication of configuration. Each repository requires its own setup for CI/CD pipeline, linting, and testing tools, leading to duplicated effort. Lack of shared visibility. Developers might lose visibility into other microservices codebase, making it harder to debug issues that span across services. Shared libraries might be harder to manage and version. Tooling and dependency management. Shared dependencies and libraries require versioning and proper management, which can add complexity. Without careful management, multiple versions of the same library may end up across microservices. Higher overhead for a small team. Managing multiple repositories, CI/CD setup, and coordination can be overwhelming for smaller teams. Increased operational complexity. Maintaining multiple repositories means more tools for code organization, PR reviews, and issue tracking. With that being said, should I choose single or multiple code repositories? Well, let's see if these conditions are met. Teams are large, autonomous, and responsible for their own microservices. Microservices are loosely coupled with clear API contracts. The tech stack or tools differ across microservices. You need to enforce strong modularity and isolation. In these cases, you should choose separating repos. The separate code repositories promote autonomy, isolation, and scalability, but introduce coordination and configuration overhead. On the other hand, if your teams are small and closely collaborate, there are frequent cross-service changes. You need a single, consistent CI/CD pipeline. Shared code and libraries are significant and changing often. You may want to choose a single repo to simplify dependencies management and cross-service chains, but risk tight coupling and slower builds. The choice depends on team structure, service dependency, and the complexity of your microservices architecture. Besides the code repository, we also have another decision made at the beginning, but swapped as the project went, which is about where to install and run the Jenkins build agent. When kicking off the project, running builds in containers is our first choice. There are some benefits of choosing containers to host the build agent. Scalability and flexibility. ECS can easily scale containers up and down based on demand. Ideal for on-demand build agent that start and stop as needed, reducing idle resources. Cost efficiency. You pay only for the running containers, which can reduce costs when builds are infrequent. Isolation. Each build runs its container, provisioning better isolation and avoiding potential conflicts between builds. Ease of maintenance. Updating the agent software is as simple as updating the Docker image, which can be done automatically using ECS task. AWS integration. ECS integrates seamlessly with other AWS services, such as CodeWatch for monitoring, IAM for secure access. Consistency. Containers ensure consistent build environments. eliminating issues caused by differences in underlying infrastructure. However, as the project goes, we start seeing the problems and the limitations from using containers, such as initial setup complexity. Set up Jenkins agents on ECS requires knowledge of ECS, task definition, and Docker container orchestration. Performance overhead. Containerized builds may introduce slight overhead compared to the native builds, depending on the complexity. Cold start latency. Spinning up containers for ephemeral agents can introduce delays for the first build. Limited customization. Containers may lack direct access to the underlying hardware for specialized builds requiring specific configurations. To overcome those difficulties, we decided to provision an EC2 instance as a Jenkins build agent. Compared with containers, EC2 instance does better in performance. Build can run natively on the VM, which might provide better performance for certain workloads. Customization. Greater control over the build environment, including the ability to install custom software or libraries. Predictability. Persistent agents means there is no cold start time. Builds start immediately if the build agent is available. Ease of setup, especially for legacy systems. Straightforward setup for teams already familiar with managing EC2 instances. Better for long-running jobs. Suitable for builds that run for extended periods or require a persistent state. As you can imagine, after switching to the EC2 instance, we also lose some advantages from the original containers. The cost. EC2 instance run continuously unless explicitly stopped, leading to potential cost inefficiencies while idle. Scalability challenges. Scaling up and down is slower and requires more manual intervention or automation scripts. For example, via auto-scaling. Maintenance overhead requires patching, updates, and ongoing maintenance of the underlying operating system. Resource contention. Multiple builds on a single EC2 instance could lead to resource contention and failures if not properly managed. Underutilization. Persistent VMs may remain idle for extended periods, leading to wastage of resources. To summarize, container is better if you prioritize cost efficiency, scalability, and ephemeral builds with predictable environments. Virtual machine is better if you need highly customized environments, persistent builds, or long-running jobs. In addition to those technical decisions with source code and build pipeline, we also have the team structure that impacts the performance and delivery. In an ideal world, specialists excel in their specific domains, offering higher quality and efficiency in their areas. For example, QA engineer for testing, DBAs for complex database tasks. Team members can dedicate their full attention to one aspect of the project without being distracted by other tasks. Dedicated QA engineers ensures thorough testing, and adherence to quality standards. Scalability allows for easier scaling, especially for large projects where certain domains, such as databases or testing, require extensive focus. Knowledge deeps. Each domain benefits from advanced technicals and tools specific to their areas of expertise. However, when working with the specialized roles team, we also see some disadvantages. Misunderstandings or delays can arise between teams, slowing down development cycles. Tasks often need to wait for another team's input or approval, increasing lead time. Maintaining specialized roles may require hiring more staff and can be costly for smaller projects. Specialists might be underutilized in some phases, leading to inefficiency. Since the team had already been established before realizing those problems, we were unable to completely replace the entire team. Instead, we identified the bottleneck and exchanged a few team members to minimize the risk. By taking this step, we start seeing the difference. Full-stack developers can handle front-end, back-end, testing, and basic database tasks, reducing reliance on multiple roles. End-to-end ownership means fewer handoffs, enabling faster development and iteration. It requires fewer team members since each developer covers a broader range of tasks. Developers can quickly adapt to changes in project scope or technology stacks. Fewer team members reduce the potential for communication breakdowns and misalignments. However, as you can imagine, the full-stack developers team is not perfect. Full-stack developers may have broad knowledge but lack deep expertise in areas like advanced database design or security testing. Handling multiple responsibilities can overwhelm team members, leading to burnout or reduced quality. Tasks like testing and database design may not receive the same attention or expertise as in a specialized team. Scaling large, complex projects can be harder with generalists if tasks require specialized knowledge or expertise. Which team will work better for your project? Here's my suggestion based on USAS Coding Challenge experience. If you have large-scale, complex projects with distinct and demanding requirements for front-end, back-end, QA, and database design, or when quality and domain-specific optimizations are critical, a specialized team may fit your need. On the other hand, for small to medium projects where speed and flexibility are priorities, for startups or cost-sensitive organizations with limited resources, for agile teams that require rapid iteration and dynamic role adjustments, the full-stack team usually outstands. Ultimately, hybrid modes often strike a balance by combining full-stack developers with a few specialists, such as a dedicated DBA or QA lead for critical aspects. This approach can provide flexibility while maintaining high standards in specialized area. Congratulations! You have reached the end of this session, as well as the entire application video walkthrough series. I hope you learned something new and found something that can be applied to your project. Thanks for watching, and good luck to your future coding challenge.